Okay, good afternoon. I'm back. This is the second video from Chapter 6. The first one where we'll be looking at a particular problem. In this video, which should be a little bit shorter than the first, I hope, I'll go through a problem, go through the steps of the problem, and I'll discuss the issues involved. Remember, we're talking about mutually exclusive alternatives. We'll select one from among, in this problem, 3 possible alternatives. These alternatives all have equal lives. This is the most basic evaluation we can use for mutually exclusive alternatives, and that is the equal life process, and we will simply look at the present worth. So I would ask you to pull up, if you would, the spreadsheet that's been posted on online. It's called Modules, and this one is the first worksheet. There is called Module 1, and for this module we'll be looking at 3 alternatives: Alternative A, Alternative B, and Alternative C. Each one with a set of cash flows, an initial investment, net annual revenues for each one, a salvage value or a market value. Again, salvage may not be the best term for that. We'll use market value, and a useful life. The internal rate of return there is something that I calculated that you can look at. I'll be referring to it just briefly. So we'll consider these alternatives. The MAR is 12%, and equal lives. Let's go through this pretty simply. I do want to point out one thing to you to start, and that is that with 3 alternatives, you'll notice that Alternative B is the one that has the smallest initial investment. And that means that Alternative B is really our base alternative. And that is, our base alternative is always the one that requires the least investment. Okay, let's look at the individual steps for this problem. I've already filled out the numbers because I can't do this interactively with you, but I will step through each one. For step 1, it says find the proper interest rate. Remember, we need an interest rate that matches the frequency of the cash flows. Our cash flows we see here are annual. Our MAR is 12%. Remember, I said if it doesn't say anything about compounding and it doesn't say anything about a period, that our assumption is that it's a 1-year interest rate, an annual rate, and that we'll just treat that as the effective rate. For this problem, we'll use the 12% as the interest rate. Step 2 is where I'm going to look at the IRR of each. Now, this is no way to compare these alternatives at all, but it does tell us, perhaps, if one alternative is already unacceptable. We can eliminate one alternative. For this problem, we can eliminate Alternative B, because the rate of return of Alternative B, 11%, is less than the MAR of 12%. So we could, I won't for this particular video and for this illustration, we could have eliminated Alternative B and considered it no more in our analysis. But I will continue to consider that for illustration purposes. Look at step 3. Step 3, find the equivalent worth for each alternative. And we're going to use the present worth. What does equivalent worth mean? Equivalent worth is a substitute term for either present worth, annual worth, or future worth. So we could have found any one of those. We could have found the annual worth of each, the future worth of each, the present worth of each. I chose to use the present worth of each. You can see underneath step 3, in cell B17, I have a label, present worth of each alternative, and in cells C17, D17, and E17, I have the function, the PV function that I used to determine the present worth of each alternative. Notice that the present worth of alternative B, which is in D17, is a negative number. We knew this would be negative. You should have known this number would be negative because the rate of return of alternative B is less than the MAR, and therefore the present worth of alternative B at the MAR will be less than 0. Since this is an investment alternative, we can eliminate alternative B again from consideration. Alternative A has a present worth of $6,600. Alternative C has a present worth of $5,900. The larger of those two is the present worth of alternative A, and therefore alternative A is the best alternative from these three. Our answer would be select alternative A because the present worth of alternative A is greater than the present worth of either alternative B or alternative C. We could have set up a cash flow tables for each one of these instead of using the table that's provided here. For each one of these alternatives, we could have developed a cash flow table that had the cash flows for each year, and we could have used an NPV, for example, to find the present value. Either way, it doesn't make any difference. You get the same answer and come to the same conclusion that alternative B is the most attractive alternative for these three. That's the end of this module. For the next module, we'll look again at equal-lived alternatives, but we'll look at what's called the incremental analysis or incremental cash flows. And in this particular tool, we'll look at how one cash flow for an alternative compares to another cash flow for an alternative. So it's going to be a one-on-one kind of comparison. And we'll look at that in the next video.